When you have two or more related unknowns, you may be able to represent their relationship with a system of equations. That's just a set of two or more equations. Here's an example. Negative 3x plus 2y equals 8, just one equation, and x plus 2y equals negative 8, another equation. When we consider them together as a set, we call that a system of equations. Now a brace, we can see this tall brace on the left, indicates the equations that make up the system. So it's kind of a grouping symbol to group them together. A linear system consists of linear equations. A solution of a system is a set of values for the variables that makes all the equations true. You can solve a system of equations graphically or by using tables. Problem 1. Using a graph or table to solve a system. What is the solution of the system? And we're given here two equations, negative 3x plus 2y equals 8, and x plus 2y equals negative 8. And we're going to work through two methods. The first is graphing. So method 1, graph the equations. The point of intersection appears to be negative 4, negative 2 when we look at the graph on the right. So that would be the point in common between those two lines, or their point of intersection. But we should check. Check by substituting the values, negative 4 and negative 2, into both equations. When we substitute into the first equation, negative 3x plus 2y equals 8, well, we substitute negative 4 for x and negative 2 for y, and we get negative 3 times negative 4 plus 2 times negative 2, and we're checking to see, does that equal 8? And sure enough, it does. So our solution checks out in the first equation, but because we're talking about a solution to a system, we also have to check it in the other equation, or equations, if we were to have a system with more than two equations. So we check on the right, and sure enough, the second equation has a solution of negative 4, negative 2, so the solution we found is the solution of the system. Now I do want to take a minute and point out how we can do this on Desmos. So on Desmos, method 1 is at the top, and I've already entered in the equations. So as you graph, you would just be graphing these equations, and remember, you don't have to write them in any particular form. Desmos will figure out what it is you'd like to graph and graph those for us. But here's the graph of the first equation and the graph of the second equation. So if we needed to find this point of intersection, remember, just click on it. It's one of what Desmos considers critical points, or points of interest. And then if you click again, that label will actually stay in place. So same problem, but completed on Desmos. Same solution, negative 4, negative 2. And our second method, use a table. Write the equations in slope-intercept form. In order to use a table, we need to rewrite the equations so they are in slope-intercept form. And that's true for graphing calculators and for Desmos. And we'll take a look at both of those options here in just a minute. So to rewrite the first equation in slope-intercept form, we'd find y sub 1. We can tag it with a subscript 1 to represent our first equation and help us tell it apart from our second equation, equals 3 halves x plus 4 in slope-intercept form. And then our second equation works out to be y sub 2 equals negative 1/2 x minus 4. We can enter those equations in the y equals screen on a graphing calculator as y1 and y2, and then view the table. On the graphing calculator, we'll start typing in x values as inputs into both functions, and the calculator will find or calculate the y values that go along with those. So in the table, when x equals negative 4, highlighted here in the screenshot, both y sub 1 and y sub 2 equal negative 2. So we could see here we have a point in common. When x is negative 4, y is negative 2, and that would be the solution of the system. So again, we found the same solution, just using a very different technique and looking for the point that is in common between the equations. You can also create a table. We can see method 2 here shows a table. I shut off the equations from above, and it works really similarly. First, you rewrite the equations in slope-intercept form, and then you add the expressions, set equal to y as column headers, and plug in input values, allowing Desmos to calculate the output values for you. So you might want to start with one that we commonly use first, because 0 is pretty easy to work with, and we find that our first equation equals 4 when x is 0, and our second equation equals negative 4 when x is 0. Now, another thing we may want to do is turn on each of these functions There we go. So we can see both a red point here to represent 0, 4 for this function, and a blue point down here to represent 0, negative 4 for this function. Now maybe we try 1. It looks like they're getting farther apart from one another. When x is 1, y sub 1 is 5.5. When x is 1, y sub 2 is negative 4.5. So maybe we should work in the opposite direction. Nice thing is, this happens really quickly and efficiently for us. That's better. Now we've got this trend going where the points seem to be getting closer together. Remember, our goal is to find the point they have in common. So negative 2, getting warmer. Negative 3, negative 4. And that's kind of hard to tell, but they are overlapping there. And if we went one farther, we'd see they've already intersected and are now starting to get farther apart again. We can also look here on the table, similar to the way we did this on the graphing calculator. When x is negative 4, y is negative 2 in both cases. So that would be the point in common and the solution to the system. Your turn. What is the solution of the system? X minus 2y equals 4, and 3x plus y equals 5.